Hey guys, we're going to be going through a lesson here on graphing systems of equations. Um, so let's go ahead and get started. Bye, everyone. That whole screen. Get out of here. Thank you. All right, here we go. Now, systems of equations. Okay, systems of equations is basically two or more lines. Okay, or two or more equations. Um, for right now being put on a graph. Okay, essentially it's used for comparison. So these are the three possibilities of what can happen. Okay, and there's specific terminology, mathematical terminology that we use for this. So the first one, okay, and this is the most common, is you have two lines on a graph, like you see here, two lines on a graph that they cross. Okay, this intersection point here, that ends up being our solution. Okay, where two things are even, two things are equal. Okay, now that is considered consistent because it has a solution, and independent because there is one solution. Okay, when you are doing the problems, you would basically name this point. So remember, x 1 2, y is 1 2 3 4. Okay, now the next one is an infinite number of solutions. Now, this happens when when you plot the two lines, you graph the two lines, and it is the same thing twice. Okay, you'll see me a lot of times draw a second set of arrows on it, but it's two lines that are laying one on top of the other. So, yes, it is consistent. There are solutions, but the answer that you give is dependent upon where you're at on the line. There's an infinite number of solutions. It's all of these data points that are on this line are all solutions. It's not like an independent where it's one spot that they touch. Okay. And then the last kind is no solution. So on a no solution, notice we have two parallel lines. Okay, the lines never touch. This is considered inconsistent. Okay. So those are the three main types that we're going to see. Again, the first one, consistent, independent, this is the most common. Okay, now let's kind of look at some of these graphs of these. So for this first one, okay, we look at this particular one and we have two parallel lines. So these are two parallel lines. This would be considered inconsistent. Okay, they do not touch. Now, I want you to notice something about these. The slopes are the same, okay, but the y-intercepts are different. Okay, so when you see that you have same slopes, that's going to tell you it's something weird. Okay, and this one they never touch because they start at different spots, so it'd be inconsistent. Now, what would you write for your answer to this? You would write no solution. Okay, so the things you're going to see with the equations: same slope, different y-intercepts. Okay, and that can be seen with slope-intercept form. Okay, the next one, notice they do cross. They cross right here. Okay, so this would be consistent, independent. Consistent, independent. And I do want you to notice that they have different slopes. This one has a slope of -1. This one has a slope of +1. So understand, if we have different slopes, they are going to cross somewhere. We're going to have a solution. This one in particular, it would be 2 on the x and -1 on the y. Okay. The last one we have here, this, the last one here, we have, notice it looks like one line on the graph. So this is considered consistent dependent. Okay? And I want you to notice if I took this second line, this 8x minus 4y equals negative 12, if I put this in slope-intercept form, minus 8x, drop it like it's hot, divide everything by negative 4, I end up with the exact same slope-intercept form. Exact same. Okay, so that's what's telling you it's the same line. It is consistent dependent. Okay, now let's go ahead and look at our worksheet. Okay, if you need to pause the video and pass out the worksheet to everyone, if it is not already passed out, go ahead and pause the video right now and do that. Now, we're going to go through the first 4 of these problems together. What you're going to be doing is graphing each of these individually, and you are going to be looking for where they intersect. Okay? The one big thing you have to do, you have to make extra points. If you're already used to doing this from inequalities, it's going to be a non-issue for you. But you have to make extra points because we have to find the specific point that they intersect. So let's go and start with this one. It's already in slope-intercept form. So y-intercept is negative 8. Boom. And my slope is negative 1/2. Down 1, right 2. So from here, down 1, right 2. Down 1, right 2. And I'm going to follow that pattern the other direction. So I'm filling my graph with data points from that particular line. Go ahead and connect it. Aye! Wrong type of, get out of here. I want a line. There we go. One of those red dots is going to be my data point. Okay, now I'm going to graph the other one in blue. So with blue dots, so y-intercept's negative 3, so down 3. And my slope is negative 3/1. So that's down 3, right 1 from here. Down 3, right 1. Down 3, right 1. And they intersect right there at that data point. So I can go ahead and connect them. And then the only thing I need to do is name what that data point is. This is a consistent independent. Okay, I knew this because it had different slopes. But this would be 2 on the x and negative 9 on the y. And that's all that we do for right now. Okay, let's look at number 2 together. Numero dos. So we have our 2 equations here in slope-intercept form. Want you to notice right away, we have different slopes. Okay, the top one's negative 1/4, the bottom one is 1. So they should intersect on this graph somewhere. So let's do this first one. Y-intercept is 1, so up 1. My slope is negative, so down 1, right 4 from this spot. And up 1, left 4. Follow that pattern. Make extra points. Okay, it's imperative that you are doing that. Now, what of those red data points should end up being my answer? Second one, y-intercept 6. Slope is positive 1. So it'd be up 1, right 1 from here. Up 1, right 1. And then follow that pattern. That's going away from my line, so I'm going to go in the other direction. And right there, they intersect. I like to circle it like you've seen me do on these last couple. So there's my line. Put it on there. And now we have to name the data point. It was different slopes, consistent, independent. So my x is negative 4. And my y is positive 2. Make sure we are naming the data point in the correct order. Okay. Let's look at number 3. Again, I like to look at my problem beforehand. Okay, again, I have different slopes. The top one is 2, the bottom one is -1. So I know that they somewhere on this graph, somewhere on that graph, these are going to intersect at a perfect data point. I'm not trying to trick you with these. Okay, so y-intercept is -4, down 4. Slope is 2/1. It's positive, so up 2, right 1. 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 And I keep doing it over and over and over. I keep doing it over and over. Boom. Okay. Make my line. All right. So now we're on to our second line. Going to put this one in blue dots at least. So y-intercept's 5. That's 5. Boom, boom, boom. Slope is -1/1. It's negative, so it's down 1, right 1. From here, down 1, right 1. Right 1. And I see they hit right there. Let's connect my line. And all I have to do is name my data point. So for the x, this is 3. For the y, this is 2. Okay? And they meet at 3, 2. So again, I want to point out before we do number 4, if they have different slopes, they should meet in a perfect spot, just like you saw here. If they are not meeting at a perfect data point, then likely either your y-intercept is wrong or your slope is wrong. Okay? I'm not trying to trick you with these. They are going to hit at a perfect spot. Okay? Eventually, we'll see some that don't hit at perfect spots, but that's not for today. Now, let's do this last one together. Okay? And what I want to notice, again, I like to look at my equations. So we have, oh, look at there. Both of the slopes are 3/4, and they start at different spots. So I know before I even do anything, I know that this is inconsistent. I know that these are going to be parallel lines because they have the same slope and different starting points. So what I need to do is I still need to show it on the graph. So let's start with this top one. Red dots, +8, 3/4. I can't go up and right. That's off my graph. Down and left. Down 3, left 4. And we connect them. Connect the dots. La, 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 la. Next one. Y-intercept's -6. And again, it's +3/4. Up 3, right 4. Up 3, right 4. Up 3, right 4. I'm going to go the other way. And I connect. And I do see the parallel lines. So how do I answer that? Because it's not a data point. I have to have the 2 lines on the graph, and then I can write no solution. Okay, and that's it. All right. This is what I'm going to need from y'all. We are going to be doing the rest of that worksheet. Okay, so that's part 1. Make sure you get this review sheet or this worksheet done. This is being turned in before you leave class today. Okay, so once this is finished, turn it in. Okay, and then any homework assignments that have not been turned in need to get turned in. How do you know? Check your Canvas. Okay, if there is a grade, okay, on your assignment that is, if it's finished, it's a 5 or a 6. Some of you got a bonus point. Okay, if it's finished, it has a 5. You've shown a finished assignment. Okay, if there's nothing there, you need to get that turned in. Okay, get those homework assignments turned in. I'll be updating those grades next week. Okay, so those are the two things. I hope y'all have a wonderful day, and I will see y'all on Monday/Tuesday. Hasta luego.